welcome all of you to today's class of Pharmaceutical Organic Chemistry. I am Rosalind Mishra, ITS College of Pharmacy. Today in today's class we shall be dealing about aliphatic amines, their preparations and chemical uses. Alright. So, let us move on further. Now, today's class consists of Unit 5 of Pharmaceutical Organic Chemistry. Unit 5 basically deals with two major halves, which is aliphatic carboxylic acids and aliphatic amines. In the previous classes, we have discussed about the various heads of aliphatic carboxylic acid, okay, namely acidity of carboxylic acid, effects of substituents on acidity, inductive effect, qualitative tests for carboxylic acids, amides and esters, structures and uses of various derivatives of carboxylic acids, namely acetic acid, lactic acid, tartaric acid, citric acid, succinic acid, oxalic acid, salicylic acids, benzoic acids, benzyl benzoates, dimethyl phthalates, methyl salicylates and acetyl salicylic acids. Okay. Next, we have dealt with aliphatic amines. In our previous class, just before class, we had learnt about basicity of amines, how the basicity of amines is affected by the substituents. We shall look into various qualitative tests for amines. We shall look into preparations and chemical uses of amines. Along with this, we will have a brief glance about structure and uses of few derivatives of amines such as ethanolamine, ethylene diamine and amphetamines. Okay. Now, let us move towards preparation of amines. Okay. So, the first preparation would be by ammonolysis of alkyl halides. Alkyl halides are denoted by Rx, wherein R represents the alkyl group, X represents the halogen. Okay. R represents alkyl group, whereas X represents halogen. Many organic halogen compounds are converted into amines by treatment with aqueous or alcoholic solutions of ammonia. Okay. Now, many organic halogen compounds are converted into amines by treatment with ammonia, either aqueous solution or alcoholic solutions of ammonia. This reaction is generally carried out either by allowing the reaction to stand at room temperature or by heating them under pressure. Displacement of halogen by the amine yields the amine salt. Okay. In alkyl halide, what happens is, when an alkyl halide is mixed with ammonia, either aqueous or alcoholic ammonia, then displacement or removal of the halogen group takes place, or replacement of the halogen group takes place by amine, which is NH3. This yields the amine salt, which is substituted ammonium salt, from which the free amine can be liberated with hydroxide ion. Okay. So, this is the same thing which can be represented with the help of this reaction. An amine or a nucleophile, when placed with alkyl halide either at room temperature or at high temperature and pressure, then you all can see the halogen group is displaced and alkyl group is attached to the amine. Okay. So, the second reaction is through reduction of nitro compound. Ammonia or primary or amines can also be derived or also can be produced by reduction of nitro compounds. nitroalkanes can be reduced quantitatively to their corresponding amines. Here you can see nitroalkanes, okay, or nitrobenzene in this case can be reduced, okay. The nitro group can be reduced to their corresponding amines by reduction reaction. So, for example, nitrobenzene can undergo reduction reaction to release their corresponding amines. The third preparation of amines can be denoted as reduction of primary amides. Okay. So, amines can also be produced by a reduction of primary amides or reduction of amides. Amides can directly be converted into their corresponding amines. Okay. This reaction is carried out by treating the amide with a mixture of base and bromine. Okay. So, a mixture of bromine and base in the form of potassium hydroxide when reacted with an amide, for example, RC double bond O NH2, for example, RC double bond O NH2. Okay. So, a primary amine can be obtained. This reaction is also called as Hofmann-bromamide reaction. Reaction involving reaction between an amide, a base mixed with bromine, a base mixed with bromine, okay, also known as Hofmann-bromamide reaction. Hofmann-bromamide reaction, wherein a primary amine is produced with the release of potassium carbonate, potassium bromide and releasing water molecule. Okay. So, this was the reduction of amides. Amines can also be prepared by action of ammonia on alcohol. Okay. So, when ammonia is made to react with alcohol, primary amines can also be produced through this reaction. This method yields a mixture of primary, secondary and tertiary and quaternary salts, which are separated from each other by means of Hinsberg method. Okay. They can also be separated by means of Hofmann method and fractional distillation. However, amines can be prepared in good yield by using excess of ammonia. Okay. So, amines can be prepared also from ammonia when mixed with alcohol. Okay. For example, alcohol, ethanol when mixed with ammonia NH3 in the presence of aluminum oxide at a high temperature, that is 350 degrees Celsius, then ethylamine is produced. Further reaction yields a diethylamine followed by triethylamine. Okay. So, this is a continuous reaction wherein a mixture of primary, secondary, tertiary and quaternary amines are formed. Okay. So, at the end of the reaction, these amines can be separated from each other. They can be separated from each other by three major methods, namely Hinsberg method, Hofmann's method and through fractional distillation. Amines can also be prepared from carbonyl compounds. Okay. An amine from carbonyl compound is obtained by reductive amination. Okay. Reductive amination method reductive amination principle is employed in the conversion of primary amines into conversion of carbonyl compounds into amines. Here we can see, for example, CH3, CH2, CHO and aldehyde, okay, along with on reaction with the primary amine leads to formation of a secondary amine. Okay. That is reduction of carbonyl compound or conversion of carbonyl compound into amines. We shall discuss the preparations of amines again, that is, there are 5, we have been discussing 5 major reactions for the preparation of amines. Number 1, ammonolysis of alkyl halides, that is alkyl halides getting converted into amines in the presence of ammonia, in the presence of the nucleophile ammonia. The second reaction here is reduction of nitro compounds. Okay. Nitro compounds, here nitro group can be reduced into its corresponding amines, leading to the production of primary amines. Next, amides can also be synthesized directly from amides by reduction. Okay. So, amides can be reduced or converted into their corresponding amines by reacting with a base and bromine, okay, leading to formation of a primary amine. This reaction is also known as Hofmann bromamide reaction. Along with this, the other resulting or the other reactions are action of ammonia on alcohol. When ammonia is mixed with alcohol or when ammonia is made to react with alcohol, then a mixture of amines are formed, which is primary, secondary and tertiary amines and quaternary amines. A mixture of this amine is formed, which can be separated from each other with the help of 3 major processes, that is Hinsberg method, Hofmann method and fractional distillation. So, using these 3 methods, the resultant product can be separated from each other. Lastly, amines can also be obtained from carbonyl compound. It is obtained by reductive amination or amination and reduction of carbonyl compounds. Okay. Now, moving on to the next very important part of aliphatic amine, which is chemical reactions of amines. Let us see how amines undergo or how amine react chemically. Amines are similar to ammonia in their reactions. Okay. They show similar properties to ammonia while reacting. Like ammonia, amines are basic. Like ammonia, amines are nucleophilic and react with alkyl halides, acid chlorides and carbonyl compounds. Okay. Next, the aromatic amines, when we talk about the aromatic amines, are highly reactive and undergo electrophilic aromatic substitution. Okay. So, aromatic amines are reactive, they undergo electrophilic aromatic substitution reaction. Okay. So, now when talking about the chemical properties of amines, amines can be compared to that of ammonia. The chemical properties of amines are similar to that of ammonia. They are basic in nature, like ammonia, they are basic. Okay. They, like ammonia, amines are nucleophilic. They react with alkyl halides, acid chlorides and carbonyl compounds. So, amines give the following reactions. Okay. So, amines give the following reactions. Amines can act as a base, amines undergo alkylation reaction, amines undergo reaction involving conversion into amides, amines undergo Hofmann elimination from quaternary ammonium salts. They also react with nitrous acids, amines react with nitrous acids. They show reaction with carbyl amines, amines give or amines show oxidation reactions. Amines also show substitution in benzene ring of aniline. As we have already discussed, amines show electrophilic aromatic substitution reaction. So, they show substitution in benzene ring of anilines. All right. Now, moving on further, amines acting as base. Let us look into the first reaction where amines react as base and forms salt. Okay. In the first reaction here, amine when react with an acid, okay, amine when react with an acid forms, this is aniline when react with acid forms anilinium chloride, Okay. So, aniline on reaction with hydrochloric acid, it acts as a base and forms its corresponding salt. Very simple. When an acid reacts with a base, the product formed is a salt. Okay. So, here aniline when react with acid, it forms anilinium chloride, which is a salt. Similarly, if we take for example an aliphatic amine, then diethylamine when react with acetic acid, diethylamine upon reaction with acetic acid yields diethylammonium acetate, which is a salt. So, this is how amine act as base. Moving on to the next reaction, which is alkylation reaction. Amines react as nucleophiles with alkyl halides via SN2 substitution reaction. Okay. So, they show nucleophilic substitution reaction. When primary amine reacts with an alkyl halide, then it forms a secondary amine. This further react with an alkyl halide, form tertiary. This on further reaction form quaternary salt. Okay. So, this is how reaction of primary amine takes place. Next, for example, an alkyl bromide upon reaction with an amine, forms N-butyl amine, okay. That is, a primary amine is formed. Similarly, aniline when react with an alkyl halide, aniline upon reaction with an alkyl halide forms NN diethyl aniline, okay, NN diethyl aniline, which is a secondary amine. The third reaction here is reactions with nitrous acid. Okay. Next, when primary amine reacts with nitrous acid, as we can see here, the product form is a diazonium salt. Okay. Here you can see N2 plus a mixture of alcohols and alkenes. When primary amine reacts with HNO2 or nitrous acid, for example, aniline, if we take for example, then the product form is a diazonium salt, N triple bond N, or a quaternary amine is formed. Quaternary ammonium salt gets formed. Similarly, when secondary amine reacts with nitrous acid, then a nitrosamine is formed. The nitrosamine gets formed, that is, one hydrogen atom is replaced by the nitroso group, forming nitrosamines. Tertiary amines when reacted with nitrous acid, then the product formed is nitroso compound. Product formed here is nitroso compound. Since there is no hydrogen atom here to substitute, hence this nitroso group attaches the benzene ring. It attacks the benzene ring. Next, fourth reaction involves substitution in benzene ring of aniline. Okay. So, in benzene ring, amine group increases the density of electron at ortho and para position. So, the next group will attach to the benzene ring at the ortho and para position. Okay. So, when we talk for example, aniline, okay, aniline, a primary aromatic amine, when aniline is made to halogenate, or when aniline is made to react with a halogen, for example, bromine, what happens here is, in benzene ring, this amine group, in benzene ring, the amine group imparts or increases the density of electron at ortho and para position. Due to the presence of lone pair on the nitrogen atom, the ortho and para positions of the benzene ring becomes electron rich. Hence, the electronegative bromine or the electronegative halogen, when made to react with this aniline, they attach onto either the ortho or para position. Okay. So, when aniline is made to react with bromine, then the corresponding product which is formed is 2,4,6 tribromoaniline. That is, substitution happens at ortho and para position. So, forming a tri-substituted aniline. Okay. The reaction is very fast, it is very active. So, the two ortho group and para group are attacked at the same time. Okay. It is because of the lone pair of electron on nitrogen atom, they increase the electron density around the benzene ring. Okay. Thus, making this reaction faster. Okay. So, the substitution of bromine on the ortho and para position becomes very easy, leading to formation of 2,4,6 tribromoaniline. So, let us move on further. Nitration of aniline. Okay. Nitration reaction. Though amino group is a ortho para indicator, but when it reacts with acid, it produces a meta nitroaniline because of the anilinium ion. Okay. So, when aniline is made to react with an acid, when aniline is made to react under an acidic condition or with an acid, that is in the presence of H plus ion or with an acid, then anilinium ion is formed. Okay. That is in the presence of acid, anilinium ion gets formed. So, what happens due to this is, when ammonia group, though being an ortho-para director, when it reacts with an acid, then due to the production of this anilinium ion, the reaction moves or shifts towards the meta position. Thus, nitration of aniline, since it requires acidic condition, the product which is formed is a meta nitroaniline. The product formed becomes a meta, or the anilinium ion becomes a meta director, okay, leading to formation of meta nitroaniline. Clear? So, when benzene reacts with bromine or any halogen, then it acts as a ortho-para director. The amino group acts as an ortho-para director. But in second case, case number 2, when aniline reacts with an acid, when aniline reacts in the presence of an acid, then the intermediate which is formed is an anilinium ion. The intermediate is an anilinium ion. This anilinium ion is a meta director. Hence, the nitration reaction leads to formation of a product which is meta nitroaniline. Clear all of you? Very simple. Next reaction, which is sulfonation. Aniline reacts with sulfuric acid and produce 4-amino benzene sulfonic acid. Okay. It produces 4-amino benzene sulfonic acid. It gives bitter anion in aqueous solution. Here if you see, aniline reacts with sulfuric acid, in which the amino group is substituted with the sulfuric acid. Okay. Further, a sulfanilic acid is formed. Upon further reaction, it forms a Zwitter ion or a dipolar ion. It forms a Zwitter ion, which is a dipolar ion. Okay. So, this is reaction with sulfuric acid. So, with this, we have discussed all about the various reactions and the various preparations of amines. These are the reference which we could refer to. Okay. We have tried to discuss a few of the chemical reactions, though there are many plethora of reactions. We have tried discussing a few of them. Okay. So, with this, we end our class. Thank you for watching. Stay safe.